we are starting our second segment, and here we're going to be talking about different rules in the International Inland Rules. So the first one you see here is sound signals, and this is Rule 34. Usually this is when two boats are approaching each other. If all of a sudden you're out there sailing and you hear 5 short blasts, that's the danger signal. What they're saying is, hey, we're in danger of a collision. What are you going to do about it? And they're waiting for you to respond with 1, 2, or 3 short blasts. And by a short blast, we mean 1 second in duration. So 1 short blast means you're turning course to starboard. 2 short blasts is you're altering course to port. 3 short blasts, you're in reverse. So you should be answering the ship that is signaling you that there's a danger signal. You can read about these also besides the International Inland Rules in the textbook, pages 84 to 91. Okay, now the next is what sound signals should you use in restricted visibility. Of course, we're mainly talking about fog here, but it could be a rain squall, for instance, that restricts visibility. And so here, every 2 minutes, you, if you're a power boat or a sailboat with your engine on, you should give 1 prolonged blast every 2 minutes. And a long blast is 4 to 6 seconds. If you are a power boat underway, but you're temporarily stopped, then you would give 2 long blasts every 2 minutes. And if you're either a vessel not under command, vessel restricted by her maneuverability or by draft, a fishing boat, a sailing boat, a towing vessel, you give 1 long, 2 short every 2 minutes. So these are your sound signals in restricted visibility. Every 2 minutes, a sailboat would do 1 long, 2 short. Now, what lights should you have? And of course, in 101, you have seen this. This comes from Rule 23. If you are a power boat, then you display the lights as shown in Figure 1. And the diagram on the top left shows the sailboat powering or steaming light at the top of the mast. So that's a little bit of incorrect. It really is about halfway up the mast. It's a white light that shines in the same arc as the red and the green combined. If your vessel is less than 12 meters, 39.4 feet, then you could display the navigation lights in Figure 2. So you have your red port, your green starboard light, and instead of a white stern light, you could just have 1 white light. That's a 360 light. That's a possibility. And then Rule 25, if you're a sailboat, of course you're just going to have your bow lights, which are your red port light and your green starboard light up on the bow. And remember, they shine from dead ahead 112.5 degrees, or a total of 225 degrees. And then you have a white stern light in that back 135 degrees, equaling 360. Or Figure 4, if you're under sail, you could do what's called the tricolor. The tricolor is your red, green, and white light, but it's up at the top of the mast where it can be better seen, and usually boats that go offshore will do this. A third possibility is you can have your bow and stern lights, and then you can have a red and green light up at the top of the mast that are 360. Rule 30 is when you're anchored and you have a white 360 light that's at the top of the mast. Divers, the day signal is the white and blue code flag alpha, though you may see in the US the old red with a white diagonal. All right, this is Rule 27. And the night signal for diving is 360 red over white over red. And that is Rule 27. Our next segment is we're going to teach you some basics of navigation. In a minute, we'll go over to the chart table and we'll go over a few things, but here are the things we're going to teach you. First, how to read nautical charts and how they're different than land maps. And we're also going to teach you how to read all the hieroglyphics on a chart using chart number 1. We're going to show you how to plot a course using parallel rules or a protractor or a course plotter, how to determine distance using dividers, and what dead reckoning is, how it's multiplying your speed times time, and then how to determine or transpose a latitude and longitude. So these are the subjects we will be covering over at the chart table. Our 8th topic is basic navigation. And in your textbook, you can read or review pages 94 to 107. Now, the first thing we have to do is get oriented to the nautical chart. It's totally different than maps that you see on land. First of all, colors are important. You can see this buff color is what they use for land, and they don't really put much detail other than like a radio tower or something that might be of some help to you in navigating. But the water is very detailed, and you'll have 3 separate colors. White means deep water, and each chart will have the difference of where the intersection of the white and the pale blue is. And then you also, so pale blue is shallow water, and then you have pea green, which is areas that are covered at high tide and exposed at low tide. Also, you will see all the numbers, and those is the depth of the water. Now, this will again vary. It might be feet, it might be fathoms. In this chart, it's fathoms, and we'll show you the title page in a minute. And so it's showing us here the depth of the water in fathoms. Now, as it gets shallow, below 11 fathoms, it'll have a big number with a smaller subscript. And that means fathoms plus feet. So this 4 subscript 2 is 4 fathoms, or 16 feet. That's not right. 4 fathoms is 24 feet, plus 2 more feet. It's 26 feet deep there. All right, so the colors are very, very important. All right, now the next thing is you want to look at the title page of the chart. And first of all, it'll give the scale. This is a 1 to 40,000 scale. Now, the smaller the number, the larger the scale. And as the number gets smaller, it's like zooming in. As this number gets larger, it's a small scale chart, which means it's covering a larger area, but it's giving you less detail. So here you can see this is a 1 to 80 or 40,000 scale. All right, now the next thing on the title page we see is that it's soundings in fathoms, and a fathom is 6 feet, and fathoms and feet up to 11 fathoms. And it says this is at mean lower low water. Now, what does that mean? In Puget Sound, we basically have a mixed tide, which means we have 2 highs and 2 lows in a tidal day, and the tidal day is approximately 24 hours and 50 minutes. And the highs are uneven and the lows are uneven. So what they do is they take the lowest tide of the day and they call it lower low water, and they average it over a long period of time, and they come up with mean lower low water. And that becomes the 0 point for the charts and for the tide tables. So all the tide tables are referenced to mean lower low water. So in Puget Sound, we can have up to a 16-foot tidal range. And if you look at a spot here, it says it's 2 fathoms, 4 feet. Well, when is it that depth? It is when the tide is at 0. So that's 12 plus 4 or 16 feet at a 0 tide. If the tide is plus 12, it's 12 feet deeper than that. If it's a minus 2, then it's 2 feet shallower than that. Okay, and in Puget Sound and other areas, you have to check also your tides and your currents. Now going back to scale, we talked about scale. We saw that this whole chart is a 1 to 40,000 scale. Here's Gig Harbor with a 1 to 40,000 scale. But here is Gig Harbor with a 1 to 20,000 scale. So you see it covers less area but gives you way more detail as to what's going on. Now, the next thing we want to learn is some of the basic symbols. You should know that these exclamation points are lights, and a light is attached to land. Even if it's in the middle of the water, it's attached to land. It's not floating, and those are lights. The next thing we want you to be aware of is the compass rose. We have 3 rings or roses. The outer ring with the star is degrees true. That is pointing to the true North Pole. The 2 inner rings are aligned with the magnetic lines of force. And so this is magnetic. The middle ring is the one we're going to use. That's degrees magnetic. The inmost ring is the old point system, 32 points that equal 360 degrees. Each point is 11¼ degrees, which doesn't make sense, but 4 points is 45 degrees. And you probably see those old movies, you know, steer north by northwest. Well, that was a point on the compass. And in those days, that was as good as they could do. But now, of course, we use degrees. You see the difference between true and magnetic is called variation, and we have variation to the east. We can't get rid of variation. It just depends on where on the globe you are. So compasses are very accurate now. We're going to plot magnetic and we're going to steer magnetic. The next thing you should notice on a chart is the lines of latitude and longitude. Latitude runs east-west, measures north or south of the equator. And longitude runs north-south, starts from Greenwich, England, and goes 0 to 180 to the west and 0 to 180 degrees to the east. Latitude is 0 to 90 north of the equator and 0 to 90 south of the equator. You can see this area of Puget Sound is around 47 degrees, and each degree is divided up into 60 what they call minutes, little tick mark. Don't think of minutes as time, it's arc, it's angle. And so the 47 degrees will go all the way up to 59 minutes, and then the next one will be 48 degrees 00 minutes as we go north. Longitude, we're west of England, and you can see we're around 122 degrees, roughly 30 minutes. in our longitude. Now, latitude and longitude was invented to determine distance at sea. And so anywhere on the globe, 1 minute of latitude, not longitude, but 1 minute of latitude is 1 nautical mile anywhere on the globe. 1 minute of longitude is a nautical mile, but only at the equators. As you go towards the poles, longitude gets squeezed. All right, so we've gone over the compass rose. We've gone over the basic colors of the chart. Now, there may be symbols on the chart that we don't understand. When we see something on the chart, it's either going to be an abbreviation like Y, FL, 2.5S, all right, or it's going to be a symbol. Here's a symbol. If we go over here, we see little stars. Those are symbols. Now, what you need in order to read these hieroglyphics on the chart is you need what's called chart number 1. And this is giving you the symbols and abbreviation used on your charts. Now, for some reason, on the back page, they put the table of contents. And section A and B is kind of just like chart numbers and that kind of thing. Then you have a section which is land, all right, which is topography, things you'll find in land, symbols on the land. Then you have hydrography, all the symbols in the water. And then you have man-made things like buoys and lights. And you can see it's divided up into section from A to U. Now, if you see something on the chart that you want to find out what it is, first find out, is it a symbol or an abbreviation? So if you look at our this thing over here, we have capital Y, we have FL. So obviously those are abbreviations. When you see an abbreviation, what you're going to do is just go to the index of abbreviations in the back. Okay? And now you just look it up alphabetically. So we can see Y means it's either a yellow, orange, or amber buoy. Okay? And in this case, we don't have orange and amber buoys, so it's a yellow buoy. All right? FL, what does FL mean? Well, again, we can just look it up alphabetically, and we find that FL means it's a flashing light, okay? And we can go to section P 10.4 if we want more information. All right, but if we see a symbol, for instance, this thing, or these little asterisks along the shore, what do those mean? The best way to do it is look with these assorted symbols that they have in this section key from A to U. And ask yourself first, is it on the land or is it in the water? And this is obviously in the water, and so is this. So if it was on land, we would start looking here and see if we see something, and then go to that section and look it up. If it's in the water and we look here and we don't find anything that looks like the symbols we're looking for, then we're going to go to man-made things. And as you can see, we see this little triangle with the circle, all right, and that is buoys and beacons, section Q. So then what we would do is turn to section Q and see if we can find that. Now, when you go to the individual section, you can see there's a lot of buoys and beacons, you want to look at these first two columns. This is international, and this is NOAA charts. And then here's a description of what they are. So you find, looking on either this left or middle section here, find the one you're looking for. All right, and you can see all these diamonds with the circles are actually buoys, and buoys come in different colors. So this is how you find symbols. Look up on that back page and then see if you can find them in the section. Now this little asterisk here, all right, we go again to the back page. It's in the water, but we don't see anything like that here. So we may need, sometimes it can be sort of hunt and peck, where you take your best shot at what you think it might be. And so we could try, for instance, it looks like maybe it's some sort of a rock wreck or an obstruction. So we turn to section K. Again, it can be a little more hunt and peck. And we're going to go down our left or our middle column. Here's something that's similar, but that is not quite the same symbol. Make sure you get the exact one. And here's a plus. That's similar, but again different. So that's not quite the right one. So we're going to go through these sections, and again it's a little bit hunt and peck. We're not seeing it. We're starting to get nervous now. We don't see it. All right, up here it is. Under a NOAA chart, the little asterisk is rock awash, height unknown. So what that means is at a zero tide, it's slightly above the water. How high above the water, they're not quite sure. So that tells us that could be a dangerous rock, because if you have a plus 2 foot tide, it's probably just barely under the water and could damage your boat. And so that would be a dangerous rock. There's like 10 different symbols for rocks, and all of them mean something different, and you want to make sure you get the exact one. Okay, so that's how you look up the hieroglyphics on a chart. And one of the things you want to learn, and will be on your 103 test, is being able to look up things on chart number 1. Chart number 1 will be provided to you during the test. So it's not can you memorize all these things, it's just do you know how to look them up. All right, now the next thing we want to do is teach you how to plot a course. Let's say we're over here at Browns Point and we want to go cruising over and anchor over here in Quartermaster Harbor. And we see there's a red buoy here, and we know red right returning, we're returning from the sea. So we want to keep that buoy on our right-hand side, and we want to make sure that we clear it. So we want to plot a course that we can then steer to get to that buoy. So what we're going to do is, let's say we're leaving Browns Point, and we want to make sure we have nice clearance on the buoy. So we're going to plot a course from Browns Point and with nice clearance on that buoy. All right, now this is called parallel rules. What we're going to do is take a parallel line over to our compass rose to see what that course is. Now with the parallel rules, you must hold one side and then walk the other side. Then hold this side, walk this side. Hold this side. Now as you get to the compass rose, use the outer edge, not the inner edge, right to the crosshairs of the compass rose. Now, the next question is, are we going this way or that way? We know we're going this way, so we're going to read it here. And we're not going to use the true rows, we're using the magnetic rows. So we can put our pencil here, and then we can back this away so we can read it. And we can see here's 270, 280, 290, 300, there's 310. So it looks like that's about 312 degrees. Magnetic is our course over to that buoy. Now normally what we're going to do then is we could write that on the chart. We could write capital C for course, 312, always use 3 numbers, always use a degree sign, and then capital M for magnetic. Okay, capital M for magnetic. So then when we get to Brown's Point, we're going to steer 312 degrees, and that's going to get us over here clear of that buoy. Now the other way we could do that besides the parallel rules is use what's called a course plotter. The course plotter does the same thing, and again what we're trying to do is get a parallel line over to the compass rose so we can read the course. This one, instead of rolling though, it just slides. And you can take it right over there and again read your course. All right, it just slides. Works a little bit easier in most cases. All right, now the next thing we need is we need to know what is the distance over to that point. And again, what we would do normally is above the line, we're going to do proper labeling, course, capital C, 312 degrees magnetic. And pretend you're a kid trying to learn to write in between the lines. So we're going to do it right like that, right above the line. Then below the line, we're going to do a capital D for distance, and then we're going to see what the distance is here. For this measurement, we use dividers. Now this has like a wheel. Don't pull the arms. Use the little wheel, and we're going to go from Brown's Point over to right off the buoy. It's that distance. Now remember, 1 minute of latitude anywhere on the globe is 1 nautical mile, so we could use our latitude scale. And on this chart, you can see each minute is divided up into tenths. Remember, there are 60 minutes in each degree. So here we have 1, 2, and these are tenths. We have 2.9 minutes of latitude, so that's 2.9 nautical miles. Now if we make the mistake of doing it on the longitude scale, let's say we started here, we're going to get the wrong answer. See, it says 4.2, so that's wrong. Only use the latitude scale. So again, we've got 2.9 minutes of latitude, so that's 2.9. I'm going to write a distance 2.9. Now we don't need to write NM for nautical miles because that's all we use. Okay, there's our distance. Now another way we could do the distance is on each chart there will be a nautical mile scale. And what you want to do here is always end in the tenths. So don't start from 0 and go here, you're guessing. Start somewhere where it ends in the tenths, and you can see we get the same answer, 2.9. Okay, how to plot a course, how to figure distance. The next is ETA, estimated time of arrival. Now, in order to know when we're going to be abeam of this red buoy here, we would have to know what time we left. So we have to keep a log, And let's assume that we left here, and you normally use the 24-hour clock. And so let's say we left here at 1300. That's 1 p.m. And let's say we're doing 5.4 knots is our speed, and we want to know how long is it going to take us to do the 2.9 miles. What you would need, obviously, is a pocket calculator. You can use your phone. And remember, the formula is time is distance divided by speed. So what's our distance? 2.9 divided by, we said our speed was 5.4 knots. So that tells us it'll, what does that mean? That's decimal parts of an hour. Time is decimal parts of an hour. Multiply that times 60 to convert to minutes, and it'll take us about 32 minutes to get there. Now, we would never say our ETA is 32 minutes. We would add it to the time we started, so our ETA would be 1332 to the buoy. Okay, so how to plot a course, how to figure distance, how to do an ETA. All right, and this is what dead reckoning is. Dead reckoning is just, I'm steering a course, I'm sailing at this speed for this much time, I must be right here. So dead reckoning doesn't take into account current or leeway, and if we use GPS numbers of course and speed, then we're coming up with called an estimated position. All right, see, if there's a strong flood coming in here, we're pointing this direction, but we're going to end up down here somewhere. We're going to get pushed by the current. So generally in Puget Sound, you want to use GPS course and speed, not your knot meter and your compass course. All right, but how to plot a course, how to figure distance, and ETAs, how to look up stuff in chart number 1 and getting familiar with a nautical chart. The last thing is you want to know how to take a latitude and longitude off the chart that you can put into your GPS, or take GPS coordinates and put them on your chart. This is an important exercise to know how to do. Now let's say we want the latitude and longitude of this buoy that we're going to be passing right here. By the way, these are what's called the shipping lanes, all right? And sailboats or any boats in these lanes, other than commercial boats, have no rights in these lanes, and you try to steer clear of them. If you're crossing the lanes, you try to cross like we are right here at right angles. And this is the southern terminus of the VTS shipping lanes from Alaska all the way down here. All right, now, so what we want to do is find the latitude and longitude of that buoy. So what we're going to do is take our parallel rules or our course plotter, find a line of latitude that runs all the way through. So in this case, we have 47 degrees 20 minutes that runs all the way through. We're doing this to make sure we have a straight and true east-west line that we're not angling it. So we're going to line it right up, we're going to roll it down, and we're going to read it right off. So we can see our latitude is 47 degrees. We're at 19 minutes. We're right about here. So that looks like 19.1, 2, 3, 4. We normally round it to the nearest tenth, so I'm going to call that 19.5 minutes north. Now another way to do it, if we wanted to, is go to the longitude line, roll that over so we have a true north-south, and then use our dividers to see how far we are off from the 47 degrees 20 minutes that goes all the way through the chart. So we're going to get this to the proper measurement, and then we just take it over and drop it down from our 20 minutes. And again, we see we get the same answer. So 47 degrees with a circle, 19.5 with a little tick mark minutes north. All right, now how about our longitude? We're going to find, again, a line of longitude that runs all the way through the chart. Here's 122 degrees 30 minutes. And we're going to come over right to our buoy, and then we drop it down. Now, the thing that will mess you up, we're in west longitude, and the numbers get larger as you go to the left. We're used to numbers getting larger to the right, so be careful. So here we have 122 degrees. Here's 28 minutes. So this is 27.4 minutes west. 27.4. Now again, another way we could do it is use latitude. All right. Get a true east-west, roll it down to your buoy, and then with your dividers, see how far you are off from that line that runs all the way through. So we're measuring this, and then we take it down here, and we see we're getting the same answer. So again, 122 degrees, 27.4 minutes west. We're in west longitude. And generally you always put latitude first and then longitude. Also remember that 1 minute of latitude anywhere on the globe is 1 nautical mile. These are the skills you're going to practice when you're out on your 103 sail of basic navigation. How to look up stuff in chart number 1, getting familiar with the nautical chart, how to plot a course, figure distance, ETAs, how to keep a logbook, and then latitude and longitude. Now we also want to teach you how to keep a log. You should make a log entry whenever you undergo a major change in your course, or you pass an identifiable point, or third, you get a fix. So leave or pass a known point, major change in your course, or you get a fix, you make a log entry. Your log entry should include what time it is, what your course is in degrees magnetic, what your speed is, and here in the Northwest we pretty much use GPS speed because we have a lot of current. Your trip is like a trip odometer in your car. You could have a column for barometric pressure if you want, and then you want to have a comment like you passed this buoy, you changed course, or whatever the comment is. And you want to understand about ETAs, estimated time of arrival. And there's different ways you can calculate this. One is just the formula, distance is speed times time, so time is distance divided by speed. Now in this, time would be in decimal parts of an hour, not in minutes. You could use a logarithmic speed scale that's on charts still, or a circular slide rule where you can plug in the speed and the time and come up with the third variable that you're interested in. One thing when you do navigation is you could be pushed off course either by current, and current is really a different subject, or by leeway. And leeway is drift to leeward, and it's caused by the wind pressure on the hull and sails and the wave pressure on the hull. And the difference between the course you steer and the course you make good over the bottom, or course course made good or course over the ground, or the GPS people use the word track, that angle is the number of degrees of leeway. So you're pointing one direction, but you're actually going this direction. Now, this angle of leeway is a factor of boat speed, your underbody shape, what wave action there is, what point of sail you're on, and wind velocity. So the faster you're going, the less leeway you make, and the slower you're going, you make more leeway. Underbody shape we'll talk about in a minute. Obviously, waves have a big cause of causing leeway. Point of sail, the more you're going into the wind, the greater the leeway, and as you go downwind, you have less, up to a run where you have no leeway. And then, of course, the wind velocity pushing on your hull. You can see here that here's the angle of leeway in different wind conditions, whether you're beating, which means close hauled, or reaching, and whether it's a shallow keel cruiser or a deep keel racer cruiser, so a deep keel. And you can see, obviously, the deeper the keel, the more efficient it is at stopping leeway. And obviously, the stronger the wind, you have greater leeway, and also sailing close hauled, you have greater leeway. We have different hull shapes, and obviously a full keel, the keel is extending almost the entire length of the underbody of the boat, and the rudder is hung on the back end of the keel. A modification of that is what we'll call a modern cruising boat that will have a fin keel, but it'll have a skeg in front of the rudder. Most modern day boats, though, are what we'll call racing or local cruising with a fin keel, sometimes with a bulb, and a separate spade rudder. They call it a spade rudder. It is unsupported other than by the rudder post. So obviously this deep fin keel is going to be way more efficient than the modern cruising boat or the full keel boat. All right, now our ninth topic is anchoring. And you can see a discussion of anchoring on page 108 from your textbook, and you want to review the textbook pages 108 to 113. And this first slide shows us, there's variations of this, but shows us your major types of anchors. We have a Bruce anchor. The Danforth is the lightest. The plow is the heaviest, and it has like a pivot. The difference between the Bruce and the plow is right where you see the word plow, there's a pivot right there on the plow anchor, that the Bruce is a solid casting. All of these anchors do not hold the boat by their weight. So biggest boat in our fleet is a 44-footer. It weighs almost 20,000 pounds, and we have a 45-pound anchor. How's a 45-pound anchor going to hold 20,000 pounds of boat if it starts blowing? It can't. So weight has nothing to do with it. The weight of the anchor is just to give strength to the flukes. And as you can see from the diagram, the flukes is the part that's digging into the bottom. And then you have the shank, which is the shaft of the anchor. Now, the key to successful anchoring and being able to sleep at night is to have, first of all, proper chain. So a normal setup, sometimes they use the slang term ground tackle, is you have your anchor attached to it, you have a length of chain, and then you have your anchor rope, and collectively the chain and rope is called the rode, R-O-D-E. Some boats use all chain, other boats use a combination of chain and line. If you use line, it should be nylon line, which stretches, so you have a stretch capability. Now, minimum is you want the proper size chain, you have the proper link size, and also you also want proper length of chain. So minimum chain should be the length of the boat. Again, some boats use all chain, but minimum should be the length of the boat. Now, if you're a very heavy boat, you might want to be way more generous than just length of the boat as a minimum. And then the next thing is you've got to have proper scope. And what is scope? Scope is this relationship of how much anchor rode you've let out compared to the distance to the bottom. Now, this is from the bottom all the way up to your bow roller. So depending on your depth sounder and how it's reading, you're going to have to add something to get up to the bow roller. Typically in shallow water, less than 20 feet, you want a scope of 7-to-1. So your rode length should be 7 times minimum the distance to the bottom. Over 20 feet, say you anchor in 50 feet of water, which can happen here in the Northwest. We can sometimes anchor in 100 feet of water. If you use 7-to-1 scope, it just becomes impractical. You're not dragging your anchor, but you're bouncing off the bottom. You're bouncing off other boats as you're swinging in such a wide range. If you use 7-to-1 scope and you're in 50 feet of water, that's 350 feet of road. That's more than a football field. So again, you're just going to be swinging all over the harbor. So it becomes a little impractical. But the key to all these anchorers are the flukes. The pull must be parallel to the bottom. So the more the boat pulls, the more it digs the flukes into the bottom. And that's proper chain and proper scope. And that's how you achieve that horizontal pull that's parallel to the bottom. 5-to-1 is a minimum scope you should use. Increase it if you have strong wind or current or large tidal differences. If you're only going to be there for like a little lunch stop and somebody is staying on the boat the whole time, you could go with a little less than 5-to-1 on a temporary basis. But normally 5-to-1 is a minimum, 7-to-1 is ideal. Obviously, you pull the anchor out of the bottom with 1-to-1 scope. 2-to-1, you got a 45. That's not going to do it. See, 3, 4, 5. 7-to-1 gives you that good pull, but over 20 feet, that gets a little impractical. And then you can go to 5-to-1 scope. Now, in choosing an anchorage, the first thing you're going to do is look at the chart. And you're looking for what's the depth. Is it a good depth to anchor? And you're also looking at the bottom condition. You don't want to anchor in seagrass or in rocky conditions. And then you're also looking at the geographical orientation. And by that I mean, in what direction is the anchorage protected and in which direction is it exposed? Along with that, check your NOAA weather radio for what the expected winds are. If the winds are going to come from the north, then an anchorage that's open to the north is going to be exposed. And that wouldn't be a good choice on that particular day. And then check the tide tables before you lower the anchor. My little saying is always check the book before you drop the hook. Hook is a slang term for anchor. All right, to see what the tidal range is. Here in the Northwest, we can have up to a 16-foot tidal range, and so you really have to be careful. Now, some places you sail, like down in the tropics, you might have less than a foot of tide, and then that isn't a big issue. All right, and we're going to teach you when you're out on the boat, the different anchoring choices. As you can see here in this slide, we could have one anchor off the bow, and that's kind of a universal thing that you might see anywhere, and you especially see that on areas where there's going to be wind or current shifts. Bow and stern is you normally have 5 to 7-to-1 scope on the bow anchor and only maybe 3-to-1 on the stern anchor. Only use this in areas where very little wind or current shifts, and the stern anchor is just to keep the stern from pivoting. So they're opposite each other, 180 degrees, and the stern anchor is just keeping the stern from wiggling around a little bit. When I was a kid growing up in Southern California on Catalina Island, this was the type of anchor everybody would employ. Now, here in the Northwest or other places where you have deep water right up to shore, you might drop a bow anchor and then tie to shore with a line. Or they have the Medmore where you're tying to the dock with a bow anchor. In tropics where you have steady trade wind breezes, you might have 2 anchors off the bow in about a 45-degree angle to equalize the load. And which one of these you choose, of these 4 choices, either could be the confines of the anchorage. So there are anchorages up here in the Northwest where you have to tie to shore because the anchorage is shallow, it's narrow, and there's no room to swing all the way around like you would on a bow anchor. The other thing is precedent. The first guy in sets the precedent. Everyone must follow suit or go somewhere else. All right, and then when you're out on the boat, you're going to learn how to test the anchor to make sure it's holding. You first engine in reverse after you've got the anchor down and cleated off. With your proper scope, you are going to put the engine in reverse about 1/3 of your total RPMs, and you're feeling the anchor line for any vibration. Vibration is kind of like a fish nibbling on your fish line. If the anchor is dragging along the bottom, it's sending a little quiver up your anchor line, and you can feel that. Do that for about 90 seconds. If it passes test 1, go to test 2, which you shift into neutral, and temporarily you've been stretching that line. You should see it recoil and go slack on a temporary basis. And then you're going to take a hand bearing compass and you're going to take bearings that are 90 degrees from the direction where the anchor is. So if the anchor's here, I'm going to take bearings off over here, and then any change in my position will give me the maximum change in the bearing. If I take a bearing over here, it'll be the same now, or if I drag up on the beach. So bearings 90 degrees to where the anchor is. And I say the anchor, not a beam of the boat, because modern day sailboats tend to kind of tack back and forth at anchor a little bit. So use where the anchor is, not a beam of the boat. Okay, and you're going to be spending a lot of time practicing these things out on the water.